Hey everyone, welcome to the second unit. Second unit of our online thing. We're talking about probability, and today's lesson is actually on probability. So you should be looking at this on a Wednesday or Thursday. If you're not, then you're a little bit behind. But I guess the first thing that we need to do is make a definition for what is probability. Well, probability is a measure. It is a measure of likely, how likely, and you should be taking notes, how likely an event is to occur. So probability is the measure. It's measuring how likely an event is to occur. Well, if we look at that, we might want to define this word as well. What is an event? Okay. What is an event? Let's define that word as well. So an event. What is an event? An event can be made up of one or more possible outcomes. Okay? So if probability is the measure of how likely an event, maybe say a specific event, is to occur, and an event is the thing that can be made up of one or more possible outcomes. Let's use the example of taking a die. So I've got like a dice. Can I draw a 3D dice? I'm not very good at drawing. I'm going to attempt it. Something like that. So here's a die. You know, there's number 1 there. I don't know what exactly. There's 3. And maybe here's the number 5 is here. Okay. So I've got this dice. I'm going to roll the dice. Okay, the rolling of the dice would be the event. That's the event, is the rolling of the dice is the event. If I was going to talk about probability, I would talk about maybe what's the chance that I land on the number 3. Okay, so notice that the event is the rolling the dice, and that's made up of, in this case, 6 possible outcomes, right? When I roll the dice, there's 6 possible things that could happen when I roll the dice. I might get numbers 1, 2, 3, 4, 5, or 6. There's 6 different things that can happen. All right. So if we're talking probability, we would want to measure how likely the desired event that we want is to occur. Let's say that I want to roll a 3. So we would talk about what's the chance of me actually getting a 3 when I roll a dice. So we have this formula. This is your formula for probability. So P stands for the probability of, and inside the parentheses you put the event. But for the formula, I'm just going to put the letter A here, okay? I'm just going to put the letter A for the formula. So the probability, and this just stands for your event, the probability of an event happening is equal to, on the top, you're going to put the number of desired events. Okay, the number of desired, oh sorry, now let's word that a little better. The desired outcomes. Okay, so we're going to put the number of desired outcomes over, now on the bottom we put the total number of outcomes. Okay, so in the example of our taking the dice and rolling the dice, on the top we're going to write what we want. What we want goes on the top. Okay, what we want to happen goes on the top of our formula. So if it were a specific number when rolling a dice, well, there's only one number 3 on the dice, so there's only one possible outcome in that case. So we would put a number 1 on the top. If we were doing the probability of rolling a number 3 on a dice, okay, then the chances of getting a 3, there's only one side of the dice has a 3 on it. So there's only one desired outcome. Now on the bottom of the formula, as you can see I've written here, is the total number of outcomes goes on the bottom. Well, that means that of all you gotta figure out what all the possible outcomes are. That's the number you put. Well, if you're rolling a dice, there's 6 possible outcomes. Okay, so the probability of rolling a 3 would be a 1 in 6 chance. Let's just make a little note here about answers. Okay, so answers. So when you're doing probability, I need you to realize that your answers might be in the form of a percentage. Your answers might be in the form of a decimal. Your answers might be in the form of a fraction. Okay, your answers can take on many forms. I would say if you're talking probability, probably one of the preferred answers would be percentage, would probably be the preferred way to give an answer. But it doesn't matter. You can give an answer as a decimal or a fraction. If the question specifically says, give it your answer as a percentage or give your answer as a fraction, then obviously do what the question says. If the question doesn't say, the preferred method's probably a percentage, but you'd be okay writing a decimal or a fraction. Okay, let's do an example. Let's do an example. I wonder why my thing is stuck there. I don't know. Let's do an example. Okay, let's say that I have a music list. Okay, so I've got some sort of app, and in this app I've made a list of songs that I want to hear. And in my list, let's say that I had 5 upbeat songs. And I also picked out 7 slow songs. Okay, so I've got my list of songs here, and I bring up my list and I tell my app, just to go ahead, just play a random track. Just pick one at random and play it for me. What we want to know is what is the probability? What is the probability? Just got the I in there. What is the probability that the random song is upbeat? What's the chance that it's going to pick an upbeat song when it randomly picks one of these songs? So the way I'm going to write this is I'm going to hit P. I'm going to say P for, this stands for the probability of, and in here I could put upbeat. What's the probability of getting an upbeat song? So you know your formula, that on the top you put the desired number of outcomes. Okay, so out of all my songs, how many of them are upbeat? 5 of them. There's 5. That's my desired outcomes. It picks one of those 5 songs. So my desired outcomes are 5. And on the bottom, you're going to put, now you might get tripped up and think, well, you put the 7 on the bottom, right? No, on the bottom, remember, you have to put the total of all songs. That means you need to add all your songs up. I have upbeat and slow songs, 7 plus 5. I actually have 12 songs. So that means there's 12 total possible outcomes. So I would have to put 12 on the bottom because I have 12 songs. So my probability of getting an upbeat song is 5 out of 12. And if you want to take your calculator, if you want to actually get a percentage on that, then in your calculator, just do 5 divided by 12. It's a repeating decimal. We'll round it. Let's round it to the 10th. So as a percentage, that's about 41.7% chance. So I have about a 41.7% chance of my thing picking an upbeat song. All right, let's do another example. Let's do another one. Let's say, let me clear this. Okay, let's say that I have a, let's do this. Oh, I'm on eraser. Okay, so let's say I have this, like bag here, okay? Okay, and inside the bag, let's say I've got there are some green candies, green gummies or something, whatever you want, okay? I've got these green gummies, okay? There's one here, one here, one here, one here. It doesn't matter. I'm just putting them in here. We just need a visual. Okay, and in the bag there's green candies, and let's say that there's also some red candies. Okay, so let's throw some red candies in here too. Let's put more red than green. Okay, so we got some red candies in there as well. All right, so you can't. So the game we're going to play is you're going to reach into the bag, and the bag closes like tight around your hand. You can't see what you're actually going to get, but you're going to reach into this bag, and you're just going to pick something. You're going to grab one of these candies and pull it out. Okay. So what we want to talk about is, let's say, what is the probability of getting a green candy? What's the chance that I pull out a green candy out of this bag? All right, so I don't know why I keep hitting that. So we're going to do our formula. We're going to do the probability of getting a green, okay, probability of a green candy is going to be equal to, on the top we put the desired number of outcomes. Well, how many of the candies are actually green? 1, 2, 3, 4. There's 4 green candies. On the bottom, we have to put the total number of possible outcomes, including green candies. In other words, we need to count everything. So we know we've got 1, 2, 3, 4 green, 5, 6, 7, 8, 9, 10. There are 10 candies in total. And 4 out of 10, I don't need a calculator to figure that out. 4 divided by 10 would give me 40%. I have a 40% chance of grabbing a green candy. All right, let's make the question a little harder. Let's change it up a little bit. We're gonna kind of change the question and change the event. We're gonna change what's happening in the event. Okay. Let's say that you're going to reach in, you're going to grab a candy, you're going to pull it out, and then you're going to reach in the bag again and grab a second candy. Okay, so let's just say if you choose, or if you get, I should say, if you get a red candy on the first pick. Okay, so you've reached in the bag, you've taken something out, it happened to be red. You pulled out a red candy on the first pick. What is the probability? What is the probability that you will get a green candy on second pick? Okay, now we're still keeping this a simple probability because we're telling you what happened on your first pick. Next week we'll be getting into lessons where you'll have to figure, it's called, like, there's like compound events and stuff, and we'll have to take into account that, well, maybe we got the red, maybe we got the green. We'll have to work that out, right? But for this week, we're keeping it really simple, and we're just telling you, okay, the first pick, you got a red. What's the probability that you got a green candy on the second pick? Okay, well, you got to be careful here because we've already reached into the bag and taken out a red candy. So in this particular question, let's use our little diagram. Always try draw a little diagram. It helps you out a lot. So we've actually reached in and taken out a red candy. I'm going to draw an X over this one. This is the one I took. Okay, I took that little red candy there. It's gone. Okay, that red candy is gone. I took it out of the bag. That was my first pick. Now it wants to know what's the chance that I now get a green candy on the second pick. So Again, we're going to do our formula. Probability of green. Probability of getting a green. Oh, I meant to do that one in black. Okay, probability of a green candy now. Now remember, we have to take into account that we've changed the composition of what's in there because we've already taken out a red candy. So, how many green candies are left in the bag? Well, we didn't choose a green, so there's still four. There's still four green candies in the bag. But there is one red candy now missing. So that means when we count, there's going to be one less. Okay, I actually don't need to count because I know before in the previous question there was 10 possibilities, right? Well, if I've taken one of the red candies out, that only leaves 5 red candies plus my 4 green candies. There's now only 9 candies left in the bag. So it's going to change my odds. All right, we'll plug that in the calculator and get an actual number. 4 divided by 9 is, and our chances went up a little bit, and now our chances are 44.4%. And the reason why our percentage went up a little bit is because we've removed one of the red candies. So we have now a greater chance to get the green now, right? Because one of the red candies are gone. Okay, and we could play with this and make all kinds of variations. Like, what's the chance that I took, if I took out a green on the first pick, what's the chance of getting a green again on the second pick? We could really mess around with that. One of your questions in your classwork is very similar to the example I just did. Okay, we have one more thing to talk about. One more thing. Okay, we want to talk about this idea of a complement. A complement. And no, we're not talking about, hey, that's a nice jacket you have on today or something like that. Not that kind of compliment, okay? When we're talking about a math complement in regards to probability, we're talking about a not event. Okay, I know that sounds weird, a not event. In other words, we're talking about the probability of something not happening. All right, so we're not looking at the probability of something happening, we're looking at the probability that it doesn't happen. Okay, our notation looks like this. So our notation for how we say a not event is we draw a little squiggly line like this, little squiggly line, and then whatever your event is. I'll just put A for an example. Okay, maybe probability of not upbeat song or something like that. Okay, in the ACE book, so ACE notation, or I should say, the British way of notating this, they do it a little differently. They don't put the little squiggly line, so they would put like whatever it is. Okay, they would just draw a line over the top. Okay, so you have to be aware of both notations. Okay, the British notation or the ACE way of doing it is they put a line on the top. Otherwise, the American way of writing it would be the squiggly line with an A. Okay, they both mean the same thing, just different ways of notation. Okay, but I have to you'd be aware of that because we are going to be using the ACE textbook for a lot of the stuff. Okay, your formula. What's the formula for a not event? Okay, so the formula looks like this. You could have the probability of not A happening. So it would look like this. So what this means, the probability of A not happening. So it is equal to, it's very simple. You just take the number 1, which stands for 100%, okay? You take 1 and you just subtract from 1 the probability that it does happen. So whatever's going on here, you just write it again without the not symbol, and you just say 1 minus that probability over. Actually, no, sorry, what am I doing? I'm going to mess you guys up. No, there's no over anything. Okay, we'll figure out the over when we figure out the probability that it does happen. Okay, so in other words, what you're going to need to do is to solve a not event. Is step 1 is you need to solve the probability that it does happen first. Okay, then step 2, use the formula. Okay, so you're going to solve the probability that your thing does happen, and then you're just going to stick that number into the not formula right here and get your final answer. Okay, so for example, let's say I have this wheel, okay, spinny wheel. Let's not make this too complicated. Let's just break it up into 4 sections. Okay, I got a wheel here with 4 sections. One section, let's see, is going to be the number 1. Black 1. Then we're going to have a red 2, a blue 3, and a green 4. Okay. I didn't want to color them in, so I just used the things. But we've got a red section, a black section, blue section, and a green section on the wheel. They're all equally divided amongst the 4 things. So each section of the wheel is exactly 25%. Okay, it's divided evenly into 4 sections of different colors. Let's ask the question. If I spin this wheel, let's do a probability first. What's the probability that my wheel lands on red? Ooh, I keep doing that. What's the probability that I land on the red thing when I spin the wheel? So how many sections of the wheel are red? Now this is, remember, I'm counting. I've stated in the problem that everything is equally divided here. If it wasn't, we'd have to do something different. But it's all equally divided. So how many sections are there? There's 4 sections in total. Only one of them is red. So my desired outcome is to land on the red. But how many different sections are there? There's 4 different sections. So that would give me a 25% chance of landing on the red. Now let's ask the question, what's the probability? Okay, what's the probability of not blue? What's the probability that I do not land on blue? So I win the game if I land on anything but blue. So what's the probability of not getting blue? Well, you know the formula is going to be 1 minus the probability of landing on blue. So we're going to come off to the side here and we're going to figure out what that is. So the probability of actually getting blue would be, our wheel has 1 section that's blue out of the 4 that are evenly divided, and there's 4 different sections. So that is a 25% chance. Okay, but I'm not going to write it as 25% chance. I'm actually going to write it as a decimal. Okay, and you get that decimal just by saying 1 divided by 4.25. Okay, you could also stick in 1/4 in your formula if you wanted to. It doesn't matter. Just don't write a percentage in your formula because the 1 stands for 100%. So coming back to our formula then, this is going to be 1 minus 0.25. Or you could have written 1 minus in parentheses 1 over 4. Just take your calculator and do that, and you will see that the answer is 0.75, which we could put as a percentage. That means 75%. So we have a 75% chance of not landing on the blue. Okay, and that is what a complement is. Okay, so I don't think this is overly difficult. Just one last little hint for you. On your classwork, you're going to come across a question where it's something like that. They have a wheel. I don't want to answer the question for you, but I do want to give you a hint because I know some of you are going to get stuck. They have a wheel, but the sections are not divided evenly. You know, some are a little smaller than others, type of thing. Like it's got uneven sections on it. Okay. They're going to give you a chart and they give you some fractions. Like, you know, like one of the sections might be 1/6. One of the other sections is like 1/3, and so on and so forth. Okay, so to answer this question, you're going to need to get all your fractions to have the same denominator. So you're going to need to convert all of your fractions into a common denominator. Okay, and that's all I'm going to say about that question. Make sure you convert everything to a common denominator before you try to actually figure out the question. Okay, so I think I only have you doing two questions. I think there's part like A, B, C type thing in them, but you're only going to be doing numbers 2 to 3. Uh, it's in the ACE textbook on page 159, and you will see a link to that right below this video. You'll see a link to that. Do this first, and then you're going to do what I call we call it the quiz because that's what Canvas calls it. It's not really a test grade. This is just a homework check to see if you actually did the homework. So do the homework, have the answers right in front of you, and then do the quiz and just input your answers from the homework into the quiz. Make sure you actually take the time to do this because I need you guys to understand how basic probability works before we tackle getting into more, stuff that's a little more gonna have to think about it, like compound, and then we've got independent and dependent events, like all kinds of stuff going on. Okay, we even get into like mutually exclusive, and there's all kinds of stuff. If you don't get the basics down, you're gonna be completely lost when we get to that. So that's all I have for you this week. Make sure you have this done, this lesson and the one on Monday. Make sure you have it done by Friday at 11:59 at the very latest. Otherwise, Canvas starts deducting late work for you. And as always, I am always available every morning, every school morning, I should say, not obviously not weekends. Every morning, I am on Teams chat from 9 to 10 a.m. Okay. Sometimes I stay a little longer than 10 a.m. If people come in and start talking to me, sometimes I'm there a little longer. But I am there. If you need help, please join the Teams chat on the calendar and come talk to me. All right, that's all I got for you today. Hope you guys are having a good week, and I'll talk to you later. Bye.